Yes, start it now.
Okay.
Okay. So can you see my screen?
Yes.
So as Yuri last time told us about how to create Jenkins job, and he has given us task to automate the build process. So for that, what we have done is added a webhook in GitLab. So to add that webhook, we need to go to the setting options, and then we need to go to the webhook options. Then here we add the webhook by just so we added our Jenkins project URL here, and also the secret token generated from the Jenkins. For that, we need to. This is my Jenkins project workspace, and what I have made changes in that. This was all told by Yuri last time. We need to add our GitLab repository and credentials. So here uh, I added a few of the plugins for GitLab, but the main plugins is the GitLab plugin, where it indicates the GitLab with Jenkins to trigger the build job. And in configuration of Jenkins, we add the GitLab server with all our GitLab credentials and settings like server URL, and the this credential is the personal access token that we have generated from GitLab, and it can be generated here while going into the settings option. And then second in that, then we need to choose the access token. We can generate easily the access token with the scopes. I choose the API options and generated that token, and then I place that token in this configuration option, and also select this both the settings. So now I just need to push any change made it to my any of the files in our repository. So let's start. So changes have been pushed to my GitLab. So it should trigger now my Jenkins build job. Just I will check it now. Now it started Jenkins build job. Let's check it. Also, one more thing I have done to check whether the containers, the image that is been built is running fine. I am running the containers on my Jenkins servers. For that, uh, I made some few configuration changes or added a new build options that I created execute a shell command after this job is built. So I have run a few commands to check it, and now I can just you can see that the changes have been pushed and it's showing the message. Anything you really want to add?
Hello.
Yuri, are you there?
I think we can
Hello?
also. Can you please open your Jenkins project? Means build job build. Yes. Can you please click on build trigger? Build triggers. Build triggers in the middle. Yes. Yes. In that we can. Here. Can you please click on advanced?
Can actually record now.
In advanced setting we can, yes, yeah, this
Yes.
secret token can we also use in the web hub directly. We don't need to generate the personal access token. I think I have tested this also. We can straight away
Okay.
put that the secret token of that job build only.
Okay. So you're not added the configuration for that. This you
Yes,
have
yes,
not done.
I have done that too. But I have tested with that we only need to generate the secret token of that build only
Okay. Okay.
in
Got it.
advanced setting. Yes, yes.
And anyone else want to add something?
Looks good. Looks good. Again, there are multiple plugins you can use to perform the same task.
No, there is not multiple. There is these plugins are uh, have different functions. I think as it shows.
So it is completely related to GitLab only, and mm,
I also
actually
created.
uh, I have used GitHub instead of GitLab, and just to get the push, just to trigger the job, there is one only option we require is GitHub hook trigger for GIT polling. That only option would be enough, to get triggered the job once the push happen. So I think that helps too.
Okay. I also created another job to push the my image build to ECR. So here we just need to add change the configuration option for the builds, Docker build and publish. So just we need to add our Docker registry for ECR and our ECR credentials. The only thing we require is the plugin for AWS ECR. We need to install in Jenkins. Rest process is same.
Good, good, good.
Sorry, what's going on now? Who's presenting now?
What
Hello.
theory?
Sorry, who's presenting now?
Your voice is echoing.
Every we have followed the same steps. If you want to that to share us what we have also done, we can also share. Please let us know if you want to, because the steps are the same we have done.
Yes.
Sorry, I didn't get what you said.
Hello.
Hello, can you hear me?
Yes, sir, we can hear
Yes.
you.
I was asking who is demonstrating now? Who is demoing what they did?
Actually, Sachin has already given us the demo that how he has integrated the webhook with the Jenkins jobs.
Okay.
Yes,
Yeah.
yes.
So it looks like you pushed to ECR, not to Docker Hub.
No, I
No,
have
he
created
has
both
done
the
both.
jobs. One is to
Okay.
Docker Hub and another is to AWS ECR.
Okay.
Yes.
So did you experience any issues when you were doing this?
No,
I,
for now.
Yes, it's a fresh EC2 instance, right?
yes, it seems to be fine for now. You can share, give us a few more sticky tasks so that we can learn more about it.
All right. Is there anyone else who, who wants to demo what they did? Thank you, Sachin.
Thanks.
Okay, let me share the screen.
All right.
Sachin, can you please give me the permissions? Hello.
Yuri is the host.
Hello.
Uh, okay. Can you please give me the permissions to share the screen?
All right. Okay, can you try and share now?
Yes, yes. Can you see my screen?
Yes.
Yes.
Yes. Actually, the source code management and the build is the same as you have just taught to us in the previous session. In that, I just have added the build triggers that it automatically triggers the build when a new commit or any merge command is pushed from the GitLab from our local host. Here I have just click on here this option, and then on to the advanced setting. I just generated the secret token of that particular job, and then I have copied it onto my webhook of that particular repository, that is DevOps training, and then I have added it. Let me show you. You can see here the same secret token. Here I have just
Okay.
added onto the webhook and the URL of
Okay.
that job. After that, I clicked on to the save and tested by here by push event, and also tested from the by committing the changes onto my git log, GitHub log.
Okay.
If you want me to, here I can push the events so that it can trigger the. Let me show you. Here you can see that it has successfully pushed the token to on my Jenkins, and let me show you if it has triggers the build git. Here. This is the wait,
I don't think it has triggered yet.
wait, let me show you. Let me see again. Here, 22 seconds ago it is. Let me trigger it again. Push event. Here again. It is the eighth one. And let me show on to the Docker Hub also. Actually, I have configured two of my jobs that now I'm just confused that on which of the repo it has built the training, built the code.
You can check it from console.
Sorry, unable to hear you.
You can check it from Jenkins configuration, job
Yes,
configuration.
let me check. Jenkins test, git configuration. Jenkins build should have to be Jenkins build. Last push in 3 minutes. Okay, let me commit. Let me commit from here. I think no changes I have done. Let me change. Let me check the credentials. Wait. DevOps training. So this is. I think my
Do git pull. Rishabh, do git pull.
then I have to clone again.
No, just do git pull. Just do git pull.
Okay.
Username, password.
Just save it.
Mhm.
Now you can.
Now make the changes in your commitment, bro.
Okay.
It seems it's pushed now.
Pending. Here it should be. Here it is running. I think that is the only test that may have not pushed onto the to the report. Still not here.
Just check the console output once of that job.
Here it is saying latest
I
will.
think you didn't made any changes
Just,
in the
just
file.
Rishabh, make the changes, change the path in your configuration, will make the another repo in your
No, have you made changes in any of the
Docker
file?
Hub.
Yes,
Yes.
yes. Let me change it again. 22. Let's see like this.
So make your
Git
changes in
add.
configuration repo or Docker repo.
It is pushing the trigger to the Jenkins, but I don't know why it is not pushing onto the Docker Hub.
You can make it.
Oh, I have done the changes here. It is again running. GitLab push by Rishabh. And why it is not pushing here? Maybe some issue with last.
I don't think that build triggered at all. Have you tried to build it manually without a trigger from GitLab?
Okay, let me check that also. These are already pushed from the Jenkins, but let me build it manually. I think there is no change in, but I have done the changes on the app actually. Let me see if there any changes in showing here. Here is changes are also committing, but I don't know why it is not showing here. Last updated in 14 minutes by Risho 77.
Can you go back to Jenkins, please? Let's see the logs.
Can you
Can
please
you go
say
back to
again?
Jenkins? Jenkins.
Yes, yes.
And go back to those logs that you were viewing. Open the logs. No, not the config, the log.
Okay.
Logs.
No, calm down. Yeah. Yeah.
Here.
Yes. Calm down. Down, down. Okay, put down. Okay, there's one thing we can do to try it out. Let's change the version to say version 2 in our config and build again. So this time, try to trigger it from
Yes,
GitLab.
yes. That may be the problem. Okay, let me change the config and
Yeah.
the name.
You already opened the config in another tab.
Actually,
Okay.
I also do have a question that whenever I build some changes, it pushes two images, one with the name of latest and one with the name of v1 and something else like here final.
Yes.
Save.
Two images are pushed every time.
Now should I do the commits again?
Yeah, so, hello? You mean
Hello.
it pushes twice whenever you build, right?
Yes, sir, I have done the changes on the configuration level and changed the name of the tag.
Okay, can you build again?
Yes. Okay, can I build manually or from here?
No, no, build from the trigger, let's see.
From here?
From GitLab. No, from GitLab, let's see.
Okay, I will push from my host also.
I wanted you to also change the version. Can you go to Jenkins, please?
Yeah, sure. Here?
Yeah, go to config, yes. Can you come down? let's change. Oh, you changed that tag already. Okay, come
Yes,
to
I have
advanced.
changed. Yes,
All right, go to advanced.
previously it was V1.
Go to advanced.
Let me go.
Advanced.
Okay,
Now go
advanced is
back.
there.
Advanced. Come down. Come down. Okay, can't find this anymore. Go up a bit. Up, up, up. Okay, keep tag as latest. Okay, okay. You already unchecked that before. All right. Okay, try and build. Let's see. Is it building on Jenkins?
Yes, yes, it has a successful committed. V1 image. Still not here. I think it is showing last updated in 10 minutes. What is not showing in 9 minutes, in 5 minutes. Final. Here it is final. It is showing why, but I don't know why it is showing in 14 minutes. There is also some difference in between the time on my host name. It is 15. It is showing 5:11 in the IST. Can you please check on your system, Sachin?
Yes, it's
What is the time
25.
now?
25.
Yes, and this is the reason it is showing 14 minutes ago.
Oh,
Yeah, I
Yes,
think
it is
it's just a
showing
time. It's just a time problem.
previously also. I don't know why at the time of 4 to 5 it's showing the wrong time. My host shows the wrong time actually. Why I don't know.
So it's actually building. It's just the timing that's a problem.
Yes, job. Yes. Sorry for that.
No problem.
Yes, thank you. Stopping. Yeah, just stopping issue.
anyone else would like to show? Or we should
Yeah,
continue?
you can just have one more person.
Then let me share my screen. Can you give me permission here?
Yes, sir. I'm giving you the permission because I am the host now. More make host. You are the host now, actually.
Are you able to see?
Yes.
Okay, so basic. The only difference I think we have here, I have used GitLab, and I don't have to configure the GitLab configuration, which is a little different when compared to the GitHub. My configuration part is uh, almost same. Like we have created the webhook, and we have given the credential, we have given the repository, and the only changes I have used this option, get trigger, get SCM calling, where it simply happens whenever whenever Jenkins say push GitHub, it simply trigger the job. So further it will perform a task, and I have given the repo name and also given the credential of the Docker, so it can push if any changes happen. And this is the basic configuration I've done. So let's perform this. Actually, I was. It's already on the GitHub. I can do some change. Oops, I guess it's capital. So I've done a change here, and I only need to do is push the code. Let's see. Yes. Am I audible, guys?
Yes, yes.
So all I need to do is even after commit, I have to push it. So give it a board. Get push. So once the push done, I configure the job using that particular OSM as an option. So once job has started, it will perform both the actions. It will simply catch the trigger. So it's starting to build the job and even also push the job. So we can see the console. As you see, the steps has started building the job. We get the ID here, and also it pushed the job to the Docker Hub in the end. So once it is finished, we can see our job is here.
Okay, nice.
So that is the whole pipeline.
Cool. Thank you very, very much. Very much. I think we all did well. I don't know if we have any other final questions.
No, not yet. I guess we're good. Okay, how can I give a host back to Sachin?
You can just end your sharing.
I can stop it.
Always, yeah, I can always claim the host.
Okay, where is host now? Okay.
All right, so the I'm happy we were able to get the pipeline, that basic pipeline working. Like I said, this pipeline we did is just a basic setup, okay? It can be more complex than this. Can become more complex than this. It can have more features. Like I was trying to explain the LinkedIn as part of being in the pipeline. There are other things that it can actually have, but it's something I feel you guys can also, look into in your own. There is this container scanning tool that you can use to scan your container for vulnerabilities. You can also add it as part of your pipeline. I'm sure we heard of a word called DevSecOps. That's the security part of DevOps. So you can actually decide to, scan through your pipeline and actually test it to ensure that your images that you built actually are secure and safe. So these are many more other things you can add to your continuous integration pipeline to speed up a lot of processes that would have been more difficult to do if you were doing it manually. That's the whole idea behind CI/CD. And I'm happy we're able to get that Git trigger working. I mean, that's like the most interesting part of the whole thing. So what we are supposed to do is to actually is what we did. So we see how when you make a push, it automatically triggers the build. Now you will actually see this giving so much value in when you're working with developers, and because you see that they are trying to get something quickly done, and when they have to build manually and all, it takes them a lot of time. But if you're able to set up something like this that automatically triggers the build whenever they create a push, then it becomes a lifesaver. I noticed that we are all building from the master branch, but what actually happens in reality is you don't build from a master branch. You build from maybe a staging branch and all. The only time you build from the master branch is when you are trying to deploy to your environment. That's when you build from the master branch. Are we clear?
Okay, got it.
So most of the builds, like I explained already during our Git flow class. Okay, when I talked about Git flow, I talked about pull requests, made requests, how they all come together to form the Git flow or the Git process. So what actually happens is you don't build on the master, you build on maybe staging branch and all. Okay, but it also depends on the Git flow, like I said, and that Git flow means that some businesses would decide to have a staging branch and a master branch, and decide to build from the staging branch and deploy to the staging environment, while some other people would decide to actually um, build on the master branch. From the master branch, you deploy to staging and production. So the flow varies depending on the organization and what they are trying to do. So just take note of that. But the whole process of the continuous integration is the same thing, where a commit or a merge to a particular branch will automatically trigger a build that gets deployed. So from our own end, we really did not deploy to any environment, and that's where the next stage of the course is going into. So this is basic Jenkins, and we'll look a little bit into Jenkins a little bit more later, but I want us to go into Kubernetes for now. So I don't know if we have any other questions, because I'm supposed to introduce Kubernetes to us today. So we can, have the theoretical part of Kubernetes and talk about it before we move into it in the practical form. So do we have any questions on Kubernetes, on Jenkins and CI/CD for now? If none, then I'll have to move into Kubernetes, because we're trying to work.
Sorry, but sorry to interrupt. While creating branches, while creating this task, I was facing a trouble that when I was running the job from the Jenkins, two images were created on the Docker repo. I was facing this while doing this task.
Yeah, I
As
am
an
also facing the same issue. One is with the name of the tag we have given in the group,
one with the name,
and
one with
one
the
is with the
version.
latest.
And I was doing from GitHub. I was not doing from GitLab, but was facing the same issue.
What exactly is the issue? Is it the authorization to Git to Docker Hub? Sorry, I didn't get the exact issue you said you were facing when you were trying to build a job.
And job was
Whenever
building up.
we are pushing, he's saying that whenever we push any changes to Docker Hub, then the two images are pushed each time we commit. One with the latest, one with the tag we have defined in the Docker.
Okay, yeah. So can you quickly share your screen? Let me show you what causes that actually. Any one of you facing that issue, just tell me. Let me share. Let me give you access to share your screen. I will show you what was causing that.
Prashantji, can you share?
Yeah, please give me the. I'm unable to share my screen.
Can you give access to Prashant?
Yeah, I just did.
Yeah. Are you able to see my screen?
Yes.
Yes. So can you scroll down to the Jenkins job?
Yeah, this is my Jenkins job.
Okay.
And I have done from GitHub these are the credentials for the GitHub, and
Okay.
repo. Docker repo.
Yeah.
This is the Docker repo.
He pushes,
And this
if
is
you're, so you're saying the challenge here was that he was pushing both V2 and latest, right?
yeah.
Okay. So click on advanced. So if you come down, look at skip tag as latest. If you tick that part, it's not going to push latest anymore.
Okay.
Can you see it?
Good. Thank you. Thank you.
Yeah. So if you tick it, it's not going to push latest anymore.
Oh, got it. Yes.
Because you are just doing the
Don't.
basic.
Latest. Okay.
Yeah, just tick that part. Skip tag as latest. Then it won't push both anymore. Or you can just quickly do it now. Let's see. You can quickly try it out. Let's see.
No. Here, skip tag as latest. Prashant, please
Look,
click on this skip tag as latest.
एक
just check it.
Come down.
It's not.
Come down.
I can't listen.
Prashant, just come down and check for skip. Just tag that field. Skip tag as latest.
Don't tag build as a
Yes,
Yeah,
yes.
this
Here,
one.
here.
save. Okay.
Just build the job now.
Yeah, I'm building it. Give me a minute.
You can do manual build.
No, yeah, I'm going there. Give me a second. I should change the configuration. I was having the same name altogether.
Have you tried to build now?
Yeah. No, I can try. If you can, I can try now.
All right, all right.
I can change it and. I'm changing the Ubuntu to Alpine.
All right.
Yes, it is. Yes, it's now V2 only.
Yeah.
Thank you.
So no more latest, right?
Yeah.
Here.
Thank you.
All right.
Uh, sharing. Uh,
All right. Can you see my screen?
yeah.
Yuri just wanted to know that Jenkins is completed now, or we will be learning more about Jenkins after the Kubernetes?
Sorry, I didn't get you. Your voice is very low.
I just wanted to know that Jenkins is completed now, and we are moving to Kubernetes, or we will learn about the Jenkins pipeline, code pipeline of further after the
Yes,
Kubernetes.
yes, yes. We'll see the Jenkins code pipeline actually. It's just an extra part of Kubernetes of Jenkins. So I want us to do this theoretical part of Jenkins, so we can look at the Jenkins code pipeline.
Okay.
So we most likely will rewrite. We'll do the same build, but we're going to use the Jenkins code pipeline.
Okay.
Yeah. I can just share a sample code that we'll work with, then we can get it done. That shouldn't take so much time. I just wanted to look at this Kubernetes because it's quite broad. Then we can combine everything as a single, because at the end of the day, you're going to use Jenkins to deploy to Kubernetes.
Okay. Okay, got it.
All right. So, introduction to Kubernetes. Does anybody here have any idea what Kubernetes is about? Let's just have a little engagement before I start. Anybody? Hello?
It's alternative of Docker Swarm.
I don't have any idea.
It's alternative, right?
Sorry?
No idea
It's
about Kubernetes.
a Docker Swarm. Basically, created a cluster and everything.
Okay.
Doesn't know much about the Kubernetes. Not so much clear about them.
All right. Thank you very much. So basically, I'll give an overview before I start. Um, so first of all, we did a brief on Docker, and we also did a brief on Kubernetes, but there's something that is missing. Hello, can you hear me?
Sorry to interrupt. Hello, Ever.
Yeah, can you hear me?
Your voice is breaking actually.
Is it better now?
For now, it is better.
Yes.
All right. Please, whenever it's breaking, tell me.
Sure.
So when you are dealing with Docker images and containers, we talked about applications being packaged inside a Docker image and having all the application dependencies and packages. We're able to write a Docker file to build an image. And we've also even gone to the level of being able to automate a build, okay, from GitLab down to Docker Hub. Now, it doesn't stop there. Your container is an application, okay, or is part of a major application, which requires that that application needs to get into the server where it's going to run for customers to be able to access that application. Now, having that at the back of your mind, what you see is that when you want to run a Docker application, remember we use the Docker run command, okay? Docker run command is used to run the application. Now, when you are dealing with a large scale system where your application is going to be used by, say, thousands or millions of people, you need to find a way where you can actually automatically set up these containers without having to do it the manual way of being able to maybe SSH into that server and do a Docker pull, Docker run. So if, for example, you have about 50 Docker images, it means that you want to be pulling and running 50 images, which is going to take a lot of time. Now you can say, okay, what you can do is write a Jenkins job that will automatically, pull the image and maybe deploy the image. But the problem you also see is that for high availability of applications, if you pull an image and you deploy the image as a single unit, something can happen to that image. Let's assume there's an application bug or something of that nature. That application will stop working, which will lead to a downtime. Now, you need a system that can help you not just automatically deploy these applications at scale, also create high availability for you, meaning that you can actually make another copy of the application, just the way you have autoscaling in AWS, where you can have more than one server serving users. Am I making sense? Hello?
Yes, yes. What your point is, what you are saying.
All right. So there comes the concept of what we call container orchestration. Okay. Now, container orchestration is the method you use to actually set up, deploy, manage, monitor, and scale containers in a production environment. Because the truth is that you are going to have a lot of systems where you need a lot of availability, a lot of users are coming in, your system is scaling. And if you don't have a well managed or automated method of doing this, it's going to be very difficult how to do it manually. Like I said, just imagine your application has 50 Docker images. It means you have to do Docker pull, Docker run, Docker pull, Docker run. Like I said, you could also automate this using a bash script or using Jenkins, but the problem is there are other things that container orchestration can do for you that you cannot do manually using Docker pull and Docker run. That is where container orchestration comes in, and this is where Kubernetes fits into. So that's basically what Kubernetes is. Does it make sense now? All right, so these are a table of contents. The first thing we'll talk about is what is container orchestration, the examples of container orchestration, what is Kubernetes, Kubernetes control plane, and the different components of the Kubernetes master node. We have the API server, we have etcd, we have the control manager, and we have the scheduler. And then we'll move on into Kubernetes worker nodes. Within the Kubernetes worker nodes, we have 3 worker nodes. We have kubelet, we have Docker, and then we have kubeproxy. After that, we'll talk about Kubernetes objects and resources. We have what you call your node, your namespace, the service, and then other Kubernetes objects. We have the pod, the replica sets, deployments, volume, secrets, and then job. And then we'll talk about how to administer your cluster and what it entails. Kubeconfig, the kubectl commands. And then Kubernetes manifest file. What's the Kubernetes manifest file? What does it do exactly? And then we'll go into doing some practice on it. Are we together?
Yes.
Hope my voice is clear enough now.
Yes.
It is better.
All right. So what is container orchestration? Container orchestration, first of all, is the process of running hundreds to thousands of containers in a more controlled and traceable or trackable manner. For basic usage, a single VM can hold a bunch of containers, but when the containers increase and requirements change, a more orderly manner to achieve scale in managing containers is very crucial. Hence, container orchestration was born. This is exactly what I was trying to explain, right?
Yes.
Now, there are different container orchestration tools, which makes creating and managing hundreds to thousands of containers much easier. And here are some of them. That's why the Docker Swarm that someone said was actually correct. So we have Docker Swarm. We have Kubernetes, which is where we are focusing on. We have the core OS fleet. We have ECS. We have ACS. We have Diego, and then we have Google Container Engine. So all these tools practically do the same thing. Okay, what I mean by the same thing is that they are all container orchestration tools and services, and they make it easy for you to deploy containers at scale. But our focus is going to be on Kubernetes. Docker Swarm is owned by Docker, CoreOS Fleet is owned by CoreOS, ECS is owned by AWS, ACS is owned by Azure, and then we have Diego by Cloud Foundry, and then Google Container Engine, which is the same thing as Kubernetes basically. So ECS and ACS are more proprietary to Azure and AWS.
Okay.
Any questions?
EKS will be included in Kubernetes.
Sorry?
Kubernetes. AWS EKS is in Kubernetes.
Yeah, AWS EKS is Kubernetes too. That's why I didn't mention it here. The reason I didn't mention it here is the architecture of Kubernetes is almost the same thing all over. The only difference is in Google Container Engine, there might be a few tools or a few services they have that are not there. The reason is Google actually developed Kubernetes internally before they made it open source. So they tend to have a little bit more features than the normal Kubernetes or the ones provided by other providers. AWS have EKS, Azure has AKS, which are also Kubernetes too.
Okay.
Now, what's Kubernetes? Kubernetes is an open source container orchestration system for automating application deployment, scaling, and management. It was originally designed by Google and is now maintained by the Cloud Native Foundation. Kubernetes is the most used container orchestration service, and it has been adopted even by cloud providers, starting from Google, the inventors, and to AWS, Azure, and other cloud providers. I guess it's very clear for us.
Yes.
Now, the most popular container runtime used in Kubernetes is Docker, but it supports other container runtimes. Remember, during our container runtimes, we talked about runkit, we talked about LXC, okay, and other container runtimes apart from Docker. So Kubernetes does not only support Docker, it also supports other container runtimes. So that's exactly what we are trying to say here. Kubernetes promises the following features, basically. So the reason container orchestration is important are now the points that I'm going to lay down here and why Kubernetes is the most used and most trusted. One of the features is that the service abstraction, there's a service abstraction from the application. What does this mean? When you deploy an image as a container, most of the time you bind the port to that container so that they can actually expose it as a service. Okay, now when you are doing it in Kubernetes, they are actually separate entities, the service and the container. The reason for that is it helps you in terms of availability. Now, if anything happens to the pod, or sorry, to the container running, if anything happens to the container running, it will affect the service that is exposing. Okay? It will affect the service that is exposing. But in Kubernetes, they are separate entities, so it doesn't really affect it that much the way it should affect it. That's the reason for proper abstraction of the application from the service. The next we have here is availability for application or replica set. Now, with Kubernetes, you can actually make a replica of your container. Now, in auto scaling for normal applications, what you are making a replica of is both the application and the virtual machine. which can cost you a lot of money. But for that of Kubernetes, Docker is very good because when you make a replica, it's going to actually distribute across the nodes in that cluster instead of having to create a fresh VM for that application. And when anything happens to one of the containers, the other one can still receive traffic and people can still use it. The next is secure storage of credentials separated from the app. Now, I don't know if we know about environment variables. Do you know about environment variables?
It has the important credentials, which we
Sorry?
which we ignore to publish onto the some the code sites. No?
Sorry, I didn't get what you said.
No, you are asking if we know the about the environment variables.
Yes, yes.
That's why that these are the files which we ignore to publish onto the repos.
Okay, okay.
Codes like the
Yeah, so
credentials.
right. So basically, environment variables are usually used in applications for storing sensitive information, which means that instead of storing credentials inside of the application code, they can be stored inside of the server where they are needed. And when the application is deployed, the application picks it from that particular environment. Now, for Kubernetes, it creates what we call something. It creates what we have, what we call a credential store, where you can store your application credentials. It's called secrets. We'll get to application and Kubernetes kinds. Now, secrets contains credentials for your application, which makes it safer and also follows what we call the 12-factor app, which states that your application credentials should never be where your application code is because anyone could gain access to your application code. And if they do, it means that they will also gain access to your credentials. So it's actually not very safe to keep your credentials in the same place your application is. Instead, your credentials should be separate from your application. And then lastly, Kubernetes makes your applications to become self-healing. What does this mean? If anything happens to your container, Kubernetes has a way of actually making that application recover automatically from a failure. More or less, if it fails, it can start up on its own without any form of intervention from you as the user, or sorry, as the engineer. Any questions?
Hello. Can you please again tell me about the replica set?
Okay, so the replica set.
Hello. Actually, at that time your voice was breaking, and now again it is breaking.
All right, give me a second. Give me a second, let me try to restart my internet. Sorry. Hello? Is it better now?
Yes.
All right. So you were asking about replica set. So what a replica set is, it's more like a copy of your container. Okay, when you have a single container running, you make a copy of that same container, but you don't make another copy of the service, which is where the request is coming to. The service serves as a load balancer between all the containers you have running within that particular Kubernetes setup. So what happens is if any container goes down for any reason, maybe traffic or application bug, you still have one other container that is still serving requests from customers that are coming in.
Okay.
Am I making sense?
Yes.
Yeah. That's what a replica set is. All right. Moving on. So Kubernetes is a setup that works best using the concept of distributed computing. Kubernetes is made up of two broad components. We have the master node and then we have the worker node. The master node is what contains services for managing the worker nodes, while the worker node is where services and applications are deployed. All right, sorry for that break. So we have the master node and the worker node. So we'll start talking about the components individually. First, we'll start with the master node. Now, the Kubernetes master node, which is also called the control plane, is the controller that manages the cluster and applications within the cluster. The master node is made up of various components, all having unique responsibilities to keep Kubernetes running and applications within the cluster running always in good conditions. These components are installed by default whenever you run the Kubernetes installation command and run daemon processes within the master node. Now, the control plane of the master node is made up of these four major components. We have the API server, we have etcd, we have the control manager, and then we have the scheduler. We have the API server, we have etcd, the control manager, and then the scheduler. Now, let's look at each of the components. The first one we have here is the API server. This is the server that receives requests from the CLI application called kubectl and execute those commands accordingly. It can also receive direct API calls. So the API server is like what is exposed. It's more or less the interface for Kubernetes for receiving requests. That's what the API server is. The next component we have here is etcd. Now, this is the database of memory storage for the Kubernetes cluster. It stores all configurations of systems and applications within the cluster. So just call etcd the memory, I mean the storage of the cluster. Okay, this way everything that the cluster knows actually stays inside of it. This way it knows what is going on. This way it understands where it stores configurations for the Kubernetes cluster, not really for. Okay, also application configurations that we talked about also are stored in etcd, but etcd keeps all the information. Okay, all the knowledge of the cluster is stored inside of etcd. That's where it knows everything. The next we have here is the control manager. This component is responsible for most of the collectors that regulate the state of cluster and performs a task. This component is responsible for most of the collectors that regulates the state of the cluster and performs a task. So this is like the, should I call it, the main authority behind the cluster of everything that happens. Is the one that controls, manages, and executes operations. Now, whenever you're communicating with Kubernetes, when you send a request, you usually send it to the API server. When that request goes to the API server, that request is actually validated and then sent over to the control manager to execute. Just the way your keyboard is what sends input to your system, okay? And it travels down to the CPU where that operation is practically executed. So you can call the control manager the CPU of the Kubernetes control plane. Does that make sense?
Yes.
Yes.
And then the last but not the least is what we call the scheduler. This is responsible of scheduling pods on the worker nodes in the cluster. Now, the scheduler is the one that actually performs what we call the deployment of your containers. In Kubernetes, containers are actually called pods. I was going to get there, but we don't call them containers in Kubernetes. The concept of containers is quite different in Kubernetes. But what you call an application in Kubernetes is called a pod. We'll get to pods and see what pods actually are. But let's take a look at the worker nodes. Now, what's a worker node? The worker node is where pods are deployed and where the application run. It receives instruction from the master node. The worker node is also a virtual machine or an EC2 instance. So it's just like your master node, okay? Your master node can be a virtual machine or it can be a managed service, okay? But your worker node is usually a virtual machine. But as we know, it's changing gradually because the worker node can actually become serverless pods, which is what AWS Fargate is offering at the moment. But before now, your worker nodes were actually virtual machines or EC2 instances, as the case may be. So if you're in an on-prem environment, your master node and your worker node are going to be virtual machines. There's no two ways about them. But on the cloud, you can actually decide to use maybe AWS EKS for your control plane or your master node. So in that case, you do not manage the etcd, you don't manage the control plane, the control manager, you're not in charge of anything. AWS handles that part for you while you focus on the worker nodes and ensuring that you secure them, ensure that they are actually what they should be. But in the case of on-prem, you are going to be in charge of both the master node and the worker node. So the worker node, just like the master node, also has some components within it. And these are the components. We have the kubelet, we have Docker runtime for application container, and then we have the kube proxy, which serves as a proxy within the cluster, which means what creates network within that particular cluster. This is a clear diagram of everything. I don't want us to look at the diagram very well. If you have any questions, just ask. If you don't, just tell me it's okay so that we can move on.
Yes, it's okay.
All right. So I'm sure we see how a Kubernetes cluster looks like with the master node and the worker nodes, and each of those components we just talked about, right?
Yes. Ever, is this how much is remaining for today?
We just have a few minutes left, but I can pause here because I know we'll spend some time. I can pause here, then we'll continue the next class.
Yes, yes, because it's
Yes, that would be
already
fine.
means it will
Too
start
much.
going from over the head.
Yeah, yeah, yeah. I know. Actually, I didn't plan to finish it because we still have a lot to cover. So we
Yes,
can
yes,
stop
Yes,
here
yes,
and then finish up in the next class. Is that okay?
yeah, yes. That will be
yes,
very
yes.
good.
Thank you so much for an
By the
All
time
understanding.
we
right.
will revise it.
Thanks, everybody.
Thank you.
Thanks.